In this video, we'll be talking about sample spaces and events. This is our first video in our probability unit. Here we go. So we got our sample space, which is a set of all possible outcomes of a random process or experiment, and an event is a subset of a sample space. All right, pretty abstract language, but let's go ahead and jump into it with an example. We're going to roll a fair die twice, and you're going to record the pair. So this is a random process because we don't know ahead of time what the die is going to do. I mean, you could have some special instruments that would help you predict it, but in general, to the naked eye, we don't know what that dice is going to do until it lands. And we're going to record the pair. And so what's the sample space? It's just all the possible outcomes, and the outcomes is just something that could happen when we do this. So by now we're pretty used to counting things and trying to do so in a systematic way. And it turns out in this case it's pretty systematic. You could have 1, 1, 2, 1, 3, 1, 4, 1, all the way to 6, 1. And we'll say the rows here are die number 1, and then, or roll number 1, and then this is die number 2, or roll number 2. And so then here you'd have 1, 2, 1, 3, 1, 4, and so forth. And then we'd have the diagonal here, and then I'm just going to put dots because otherwise I'd be here for quite a long time listing all that out. And so this is our sample space, this whole set of possible outcomes. What's the size of that sample space? S, which will denote the sample space, that's a set. The size of that sample space is 36. And you could go ahead and count all of them one by one if you had to. It's also nicely visually laid out here. We have 6 by 6 grid, which means 36. And that's basically what the multiplication rule is saying, right? It's a first choice. I could have 6 options for the 6 faces of the die. And then second choice, or second step, 6. So that's 6 squared, or 36. All right, so that's what a sample space is. It's just a set of all possible outcomes. And what's an event? We'll all define an event in this situation. Event A will be the numbers on the pair are matching. So for example, event A could be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. There we go. So A is a subset of our sample space, just as I defined above. So we have this larger sample space. That's our sample space. That's the set of all possible outcomes. And then an event is just a subset of it, so a smaller piece of it. Listing out that set, it's 1, 1, 2, 2, all the way to 6, 6. And the size of that set is 6. All right. A common, or I wouldn't say common, but an event that is usually of interest when we're dealing with probability is the complement of an event. And a complement here, I think your book didn't use that notation, sorry. I think your book used the bar notation. So this is a complement. And so if A is the set of all pairs that have matching numbers, then A complement equals the set of pairs that aren't matching. So for example, right, we could have 1, 2 in there, 2, 1, and many others. I don't know, 1, 5, there's many. And there's a couple of different ways of counting this. I'd say the easiest way is just to count that if the total size of the set is 36, so that's the whole sample space, and we know that A is a subset, which was the matching amount, and that's 6, so size of A equals 6, then the size of A complement equals 36 minus 6, which is 30. So that's one way of counting it. What's another way of counting it? Another way of counting it is to say, using the multiplication rule. So our first choice we have is we can choose from 6 of the 6 of the dice are our first step choice. And then our second step choice would be that you could have 5 of them because they have to be different. You can think of this in terms of tree diagrams as well, right? We can have 1, 2, 3, 4, 5, 6 for our first dice. If 1 was our first dice, then we could only have 2, 3, 4, 5, and 6 for our second. Let's do 5 as our first dice. 5 would have 1, 2, 3, 4, and 6. And in general, all of these are going to have the same amount of arrows coming out of it. So we really have 1, 2, 3, 4, 5, 6, and you have 6 groups of 5 elements each. And so that's 6 times 5, which equals 30. So lots of ways of counting, just as we did in the counting section. All right. Okay, and I believe that's going to be it for this video. In the next video, we'll start talking about probability functions on sets, and in particular probability in an equally likely setting. I'll see you in the next video.